All right, so we are working on a whole diagnostic test from beginning to end. This will be the first video in a series of videos going over a whole test. If you pay attention and write stuff down, you will hopefully not just barely pass the Algebra 1 STAAR test, but get a master's and do something with the rest of your life. All right, so we've kind of gone ahead here. Right now, if you read through this, it says we got a restaurant. Each box contains 8 jars. That's why I put each box equals 8 jars. It says Y equals the total jars. X equals the number of boxes. All right, so we're going to make a little equation here. Y equals 8 times the number of boxes, but I'm not going to use the word boxes. What letter represents boxes? X, put 8x. Now, here's the thing. The cook used what? 2 jars. So I'm going to put, if he used 2 jars, basically what does that mean? Whatever he had, he has to do what? Take it away. Using means taking stuff away, right? If you use something, if you have $10, but you use $2, it's like saying 10 minus 2. So this right here would be your equation, and you'll clearly see the answer. All right. So what does the 8 represent? The amount of jars per box, and then the cook used 2, and that's what you should do. All right, moving on to question number 2. Let's take a look at it. Here we go. Question number 2. It says, which expression is equivalent? What's another word that means equivalent? Equal. Just put equal to this right here. All right. On my phone, it's going off. Don't worry about it. I don't care. Now, right now, we're going to show you a wrong answer. This is a wrong answer. You should know how to use what's called the distributive property. All right? The distributive property basically means multiply. What is 7 times 4, everybody? 28. What's x times x? X squared. Very good. What's 7 times 5? 35. All right, and we put an x right next to it. So the product of 7x times 4x plus 5 is 28x squared plus 35x. So this is a wrong answer because we need it to be equivalent to this one, right? So let's take a look at answer choice G. We have negative 7x parentheses 4x minus 5. What's negative 7 times 4? Negative 28. X times x is x squared. Negative times a negative. What's a negative times a negative? Positive. We got positive 35. And what do we got to stick next to it? An x. Do these match? That's why it's the answer. Now, what I'd like you guys to do, to not even have to do any math on this, what I'd like you to do is I'd like you to go to Desmos right now, if you would, please. All right? Let's go to Desmos. You should have it already up, Desmos test mode. We're going to type in the original expression. The original expression was negative 28x squared plus 35x. That was the original expression. Let's just type in our answer choice. Negative 7x, open parentheses, 4x minus 5. What do you guys notice about our answer and the original expression? They're the exact same graph, all right? If they're the exact same graph, what does that tell you? That tells you that's the answer. You're playing the matching game. Let's write down one of the answers that's wrong so you can see why this is the wrong answer. Would you guys agree this was one of them that we said was wrong? Is the green and the red the same? No, it's not. It doesn't match. Only these match, and that's why this is the right answer. So, what could you do in Desmos, everybody? In Desmos, play the what game? Not the guessing game, the matching game. Because Desmos does graph in terms of x. It graphs in terms of x. All right, so for the people who want 100, what should I see on their paper? That's all you got to see. It's super easy. Like if I see it, by the way, do you think I'm going to remember what I wrote down? Absolutely, because the process stays the same, even though the numbers change. All right, 1 second. All right, if you guys would, right now, This one was like a gimme. What are we looking for? Something that has what? No solution. So basically, when something has no solution, could you guys write parallel lines? That's it. That's all I want you to write. No solution means it has to what? It has to have parallel lines. Would you guys agree that it's pretty obvious which is the answer? Do not tell me if you got this one wrong. I don't want to know. All right. What do we call a point where the two lines intersect? That's called a solution, right? So these obviously have a solution. Now you're like, what about these? Would they eventually cross somewhere over here? Yeah, so they have a solution. We just can't see where it is, but they obviously have a solution. So obviously the answer is D. These are parallel lines. They will never intersect. So on your paper, what's the only thing I expect you to say? Parallel lines, no solutions, answer choice D. Okay. This is something new. We have not taught you this yet, all right? This is an exponential graph. So what I'd like you to do is I'd like you to write the parent function, all right, for all your exponentials. So I want you to understand the A value represents what's called your initial value. And the B value is either a growth or it's considered to be a decay factor. So I put growth slash decay factor. This is very easy. If the B value is greater than 1, that's what's called a growth factor. But if B is less than 1 but greater than 0, which basically means it's a fraction, then it's decaying. All right? Does anybody want to take a look at this? I know you're writing stuff down and you're trying to process it. Does anybody want to guess what our A value is and what our B value is in our little function right here? Go ahead. A is 8, correct. 0.25, also known as a quarter, is B. Now, everybody, could you please write, this is your exponential. You're not going to get a whole bunch of questions on exponential functions, but this is one of the 3 functions that you need to know. The first one is linear. The second one is quadratic. The third one is exponential. So, being that you guys don't know very much about exponential functions except what I just told you, all right, is this considered to be a growth or a decay factor? What would you guys say? Decay. It's getting smaller. Okay? So what I'd like you to do right now, after you've written this down, what I'd like you to do is type it into Desmos with me. Type in y equals 8 parentheses. So here we go. Go to your Desmos. We'll clear this out. We're going to go y equals 8, open parentheses, type in a 0.25, close it, and you see where it has a to the power of b right there? Click that guy and raise it to the power of x. And then it'll kind of make sense of why it's decaying. Can you guys see how this graph is going what? It's getting smaller and smaller and smaller and smaller and smaller. What do you think it's getting closer to? Yeah, it's getting closer to what number? 0. Yeah, it's getting closer to 0. All right. So let's take a look at what does that 0, 8 represent? The y-intercept. Could you guys write that on your paper? Ready? 0, 8 is the y-intercept. That's pretty important. All right. Oh, look, there it is. Coordinates of the y-intercept are 0, 8. Okay. Now, how could you test whether or not the other ones are true or not? It says the coordinates of the x-intercept are what? 0.25, 0. Well, let's just take a look at where 0.25 actually, oh, wrong one. 0.25 is. Ready? If I go to 0.25, is that at 0? No. All right. You guys see where I put that? 0.25? That is definitely not at 0. Now, could you guys type this in, please? Put y equals 0. I'm going to change colors. y equals 0. Does anybody want to guess what y equals 0 represents? You're like, I have no idea. It is the x-axis. You're right, it is the x-axis, but we call this a horizontal asymptote. Now, let me explain to you what the horizontal asymptote is. This graph will never actually touch it. You're like, yeah, it does. It touches it right there. But let me explain to you something. You can actually, if you zoom in far enough, do you see how this graph never actually touches it? So it looks like it touches it, right? It's getting closer and closer and closer and closer. Now it looks like it's almost there. But if we zoom in even more, does it ever actually touch it? No. That's what's called a horizontal asymptote at y equals 0. So if we go back right here, you see how it says the equation has an asymptote as x equals 0? Could you change that x to y equals 0? Now you've made it true. So the asymptote is not at x equals 0, it's at y equals 0. That's what I want you to write down on your paper. This is your learning, that you're learning what a horizontal asymptote is. All right? Think of it as the kid that always annoyed you when they said, not touching you, not touching you, not touching you. What were they being? They were being an asymptote. All right? Now, the graph includes what point? 2, 1. How could we prove that this is not true? We could go back to our graph, and what is it actually at? 2 and what? 0.5. So prove to yourself, that's like saying it's at 1/2. It's not at a 2 and a 1, it's a 2 and a 1/2. What you have to do when you guys are taking tests is you have to prove to yourself why the answer is correct. Could you prove that the y-intercept's at 0.8? So that's why you select it, not because you're guessing, because you actually have evidence. Should you have been able to do that without even knowing what an exponential function is in this particular one? Yes, if you used what? Desmos. If you use Desmos, you could clearly see that the y-intercept's at a 0.8, even without knowing what an exponential function is. Okay, here we go. What I'd like you to do right now, on your paper, can you draw a graph where the parabola is opening down right there? So draw a graph where it's opening down. That's all you got to do. Make it open down. And what I'd like you to do right now is type this into Desmos and give me the ordered pair of the vertex. Go ahead and do that right now. All right, so right now I'm going to go over here to Desmos. I'm going to clear that out, clear that out. I'm going to go ahead and type in y equals, I believe it was negative x squared minus 2x. Is it plus 3? Plus 3? Here we go. So this is what I'm expecting you to do. My vertex is at what? Negative 1 comma 4. So all I want you to do, put negative 1 comma 4. Now, what word do you think I'm going to highlight in this sentence? Bing, range, right there. What does the range always deal with? What values? The y values. So which are our stupid answers? I'm sorry, which are answers are the answers we would not want to select? A and B. Why A and B? Why are those our not good answers? Very good. So guys, could you guys put domain equals your x values. Range equals your y values. Are the y values getting bigger or smaller? So the y values are what? Less than or equal to? What's the biggest value that they get? What's as high as it gets? What's its maximum? 4. That's as high as it gets. So they're less than or equal to 4. That's why this is the answer. So literally, all you guys would have to do on this problem is look at the what? Look at the maximum and say all the y values are less than that number. Why are they less than that number? Because it's opening what direction? going down. That's why it's less than or equal to 4. Okay? Can I explain to you guys what answer choice D would be real quick? All right. That's if the graph was opening up and the minimum was at some, let's say the minimum was at -1 comma -4, then this would be the answer. Okay? If it's opening up, that's the answer. If it's opening down, this is the answer. Super easy. If it's up, it's got to be greater. If it's going down, it's got to be less. Okay? Last thing I want to talk about parabolas. If I say what's the domain of any parabola, does anybody know what the domain would be for all parabolas? The domain for all parabolas will always be all real numbers, okay? So if you see a parabola and they say, what's the domain? The answer is always going to be all real numbers. Literally, you can plug in any x value, and it goes forever from left to right. So remember, domain goes from left to right, range goes from down to up, okay? This is not a difficult problem. All you have to do is just graph it and take a look at the highest point. And that's it. All right, moving on. All right, guys, we need to go over 3 concepts right here. Ready? I want you guys to write right here. Product, quotient, product. This is your first taste of exponentials, okay? Product, quotient, not product, sorry, power. My apologies, not product, power property. Sorry about that. Been a long day. Okay, so here we go. Here's what I want you guys to write down for the product property. This is super important. 5a to the power of m times a to the power of n. This is a to the power of m plus n. You're like, what the heck is a? A is like a base. So like, for example, if I have x to the power of 4 times x to the power of 10, that would be x to the power of 4 plus a 10. And what's 4 plus 10? Boom. So this would become x to the power of 14, because you just can add them together. That's called the product property. If you have the same base, you're allowed to add the exponents. Next property, quotient property. If I have a to the power of m over a to the power of n, I am allowed to take those exponents and subtract them. So watch this. If I have x to the power of, say, 10 over x to the power of 4, this would be x to the power of 10 minus 4. Well, what is 10 minus 4? So that'd be 10 minus 4 is 6. That'd be x to the power of 6. Well, what if I trick it up just a bit? What if I had x to the power of 4 over x to the power of 6? That would be 4 minus 6. What does that become? X to the power of -2. Now, some of you might be wondering, what is a negative exponent? So back when I was first learning how to do this, when I was your age, I want you, maybe this will make sense to you. X to the power of 4 means I'm taking x and I'm multiplying it together how many times? 4 times. And x to the power of 6 means I'm multiplying it together 1, 2, 3, 4, 5, 6. But any number divided by itself equals 1. So can you guys see how these would cancel, these would cancel, these would cancel, and these would cancel? What do I have left in the denominator? So this is actually the same as saying 1 over x squared. Yeah. So here we go. So right now, what have we covered? The product property and the quotient property. We have the product and we have the quotient. See if you guys get this really quick. Ready? How about this? A y to the power of -5 times y to the power of, let's say, 12. What's y to the power of negative 5 times y to the power of 12? It'd be the same as saying negative 5 plus 12. What would you guys say? What's negative 5 plus 12? Or what's 12 minus 5? 7, you're right. So that'd be y to the power of 7. So if, remember, the product property is when you're allowed to do what with the exponents? Add them together. The quotient property, what are you allowed to do? Subtract them. The last one, power property. So here we go. Here's the power property. If I have a to the power of m raised to the power of n, I am allowed to take m and n and multiply it together. So this should be very, very, very easy. If I say x to the power of 3 and I raise that to the power of 7, what am I allowed to do with the 3 and the 7? Multiply it together. I realize that is a lot of stuff to take in. Don't worry, we're going to get to that, but I want you guys to go somewhere real quick. Go to the very front page. Does everybody see, even if you forgot the rules, do you see where these are right here? There's the rules right there. Remember when I said negative exponent? If I said x to the power of negative 2 was the same as saying 1 over x squared, there's the rule. Okay? If I have a rational exponent, if I have 1 over 2, that's the same as saying the square root of x. Even though you can't see it, that's a 2 and that's a 1. So you have all of the rules right here at the front of your test. You just have to need to know how to apply them. So we're going to apply it for this problem. Okay, so it's going to be, now what we're going to do is going to be super fast. What we just did took a long time, but what we're about to do is going to be super fast. Okay? So here we go. If you can't see it, it says 144. Could you please raise that to the power of 1? Then put k squared r to the power of 14 raised to the power of 1/2. So you're just writing it down. We'll show you how fast this is. Of the three rules that we just went over, which one do you think it best represents? The product, the quotient, or the power? Product, quotient, or power? Power property. See that power right there? We're going to take that power and we're going to multiply it to this guy. We're going to multiply it to this guy. We're going to multiply it to this guy. So you're going to multiply it to every single one of those. So I have 144, and what am I multiplying? 1 times a half. What is 1 times a half? 1/2. What is, by the way, that's a 1/2 right there, if you're wondering, that's a 1/2. What's 2 times a half, or what's a half of 2? 1. And what's 14 times a half, or what's half of 14? 7. This guy right here. That means the square root of 144, and the square root of 144 is 12. That's your final answer. Anytime you see something raised to the power of a half, that's the same as saying the square root. That's something you might want to make sure you know. All right? X to the power of 1/2 is the same as saying the square root of x. You can put that in the bank. That's never going to change. Anything raised to the power of 1/2 is the same as saying the square root. So our answer is obviously answer choice F. Okay? If you guessed it correctly, that means nothing. Okay? You can check if you're not sure which one that other people have done, you can check it. Okay? Answer choice number 5 was C. Answer choice 5 was C. All right. What I want you guys to do right now, I realize we wrote a bunch down on number 6. We're not going to write a bunch down on number 7. Here's all I want you to write. Put 2, 2. I don't know. It doesn't want me to write there. All right. I'm going to write it over here. Put a little arrow. Quick. Get out of there. What does this point represent that I'm trying to write on? Thank you. So that's at a 2, 64. That's the maximum. Put max. Right here, 4, 0 is one of your zeros. What's my other 0? 0, 0. So literally, all I have to do is find the graph that matches those points. And that's it. So I'll type in the graph that matches it, okay? Here was the correct answer. Oh, by the way, you can actually type in h of t. Watch this. H of t equals negative 16t squared plus 64t. And if you zoom out enough, can you see the vertex way up there at a 2 and a 64, and then you have a 4 and a 0 and a 0 and a 0. So all you have to do, once again, in Desmos is do what? Just match. So far, how many have we matched so far without really thinking? This is the second one. So our answer is C. What was the other one that we matched? Problem number 2, I think it was. Okay. Number 8. We're going to quickly do this by hand, so make sure that you follow along. If you've already done it by hand, fantastic. If you haven't done it by hand, check your work, all right? What's half of 4? 2. What's 4 times negative 3? Negative 12. So if you've already done this, just check your work. If you haven't done it, then do it. We have an n. Now, if you're wondering what I'm multiplying, see that negative 0.25? Negative 0.25 is like saying negative 1/4, which is like dividing it by 4. What's 12 divided by 4? 3. So put minus 3. And what is negative 8 divided by 4? Or sorry, what's 8 divided by 4? So that's going to be positive, because a negative times a negative is a positive. All right. So here we go. Here's what we got. We got 2n minus 12. I've got an n plus a 2n, so that's a total of 3n's. And here's my final and last step. I'm going to take away a 2n and take away a 2n. I'm going to add a 3. I'm going to add a 3. This zeroes out. This becomes negative 9. This becomes 1n, and this zeroes out. So I got negative 9 equals n, and it's answer choice G. Now, guys, I got to show you guys how to use Desmos. Right now, in Desmos, I literally want you to type this in. So, in Desmos, this is how you would do it in Desmos. One line needs to be this. The other line needs to be that right there. This is the last one that we're going to do. We're going to stop the video after this. Okay? So right now, hopefully you're with me. We've got what? 4, is it 4 parentheses? So we've got 4 parentheses, what? 0.5 x minus 3. So we got one of them right there. And the other one we had x minus 0.25, open parentheses, what? 12 minus 8x. Can you guys see where the two lines meet? Where does it say? Negative 9 and negative 30. That's how you would do it in Desmos. Set them equal to each other, see where they cross. The x value is always your answer.